Hi everyone, good day. My name is Jinan Fiaidhi. I'm from Lakehead University, Ontario, Canada. And I would like to introduce this webinar about our QL4POMR Maytax project, which is with Thunder Bay Regional Health Science Center. This is a project of 5 years, and the main purpose of it is to generate a future electronic health record, which definitely electronic health record is not a new topic, and it is there, but we want definitely to generate something which is distinguished and different from what was available. So our mission is a big challenge as we are making EHR, which is the electronic health record that can connect to both sites, which is the bedside and the bench side, where GraphQL as the standard for both sites. So, and in this project, those are our team members, Dr. Arnold Kim from the Thunder Bay Regional Health Science Center, as well as our graduate students, master graduate students. They are working on thesis under our supervision, which is Darien and Peter and Mehdi. The challenge behind this project is or the big question is how to design such future electronic health record, how to make the implementation of it, how to solve the difficulties that we are facing currently, and we are expecting to face some more difficulties in the future. So implementation and bringing it to the reality is the big question for this electronic healthcare record, as well as the other big question is how to make the connectivity with people and systems. So in order to address those challenges, I'm going to leave the rest of the webinar to Dr. Sabah Mohammed to continue this webinar.
Thank you, Dr. Fiaidhi, for this introduction. And this is a big challenge, as Dr. Fiaidhi was saying, that how to connect both sides, the clinical side, or what we call bedside, with bench side, and with the electronic healthcare record, as well as the both side communication systems, whether it's people or, of course, you will say, well, that means what we are trying to advocate is not only an electronic healthcare record, but also kind of tools that connect to physicians and nurses and so forth at the bedside, and as well as to connect that whatever bedside tools to the electronic healthcare record in an effective way. That needs a bridge, and there's no standard for it. The way that physicians, clinicians connect to EHR is vary widely. And of course, the other side is to connect to the biomedical data and bench side, and that is also have a different wide standards too. How to connect both sides to electronic healthcare record and build the two bridges is our big challenge. Of course, what we designed is something really big. It starts with SOAP, which is a standard that is well accepted by clinician clerkships to write patient cases through many medical schools, and but it become the kind of norm that is used elsewhere. Also, we are designing to use narratives through kind of very innovative annotations. This is something still in the pipe, as well as to elicit information from the clinicians, physicians through chatbots. And I will later my associate to speak about it. The thing is, the start is SOAP, but how to connect SOAP to electronic healthcare record like HL7 FHIR, that requires an API, and the API that we used is the GraphQL, and we found GraphQL with the Apollo Federation is a very good way to connect SOAP to FHIR, and also to connect the FHIR to a backend like a Neo4Java, and that is a graphical backend. I will speak about this later, but we need the other bridge, which is connecting to bench side, and the other bridge contains something like drug information, disease information, and other type of information, biomedical information, genetics, and so forth, through a kind of open API like Open Targets. So we connected the electronic healthcare record to Open Target. This is what we done, and we are now, whatever we speak, for example, we can describe patient cases through SOAP, like this patient 3, for example. The subjective, objective, the assessment, the plans, all there, and I can see something like a patient who's been having an encounter like an asthma. I can describe the case and see all the symptoms, all the judgment of the physicians, and what kind of indications the physician did prescribe, and so forth. What we are trying to do when we connect to the bench side, we are trying to see the other side. For example, if I'm treating asthma, what kind of genes asthma is affected? For example, if or what kind of protein a drug prescribed by the physician for asthma is linked to. Look, there are lots of things when I connect to the bench side. Like, for example, when I have patients with multiple diseases, this is so common, especially with adults suffering from different diseases. For example, if somebody has asthma, it could have hypertension and so forth. So there are multiple things, and there are lots of medication prescribed for all these encounters, and that means the patient will have a lot of medication in his whatever arena that he's taking, and that will cause a lot of interaction between medication and so forth. So I can use, for example, the bench side to see what, for example, if the physicians prescribe salmeterol as a patient, as a medication to asthma, what kind of alternative medication to that? I can see it easily. I can see what genes associated with specific type of atopic asthma, for example. Those are the genes. Then I can relate if that gene also connected to other type of encounters like hypertensions. So I can find relations. For example, if I prescribe something for asthma, it could affect the other condition, which is the hypertension. So in that case, seeing whatever on the bench from the bedside, I can prescribe the best medication for asthma or whatever medication. I will leave the continuation of this webinar to my brilliant associate, who's taking over the lead of this project, Mr. Darien Sawyer, who is going to tell us how to connect, how to use SOAP at the bedside at our QL4POMR, how to connect SOAP to HL7 FHIR, and how to generate the patient summary when I need it for referrals, and also how to connect SOAP to Open Targets, as well as how to communicate the the patient with how to communicate with patient and physician, so they fill through the chatbots, the SOAP if needed. That's through something we call AWS Amplify. Thank you so much, and we appreciate this opportunity to introduce our QL4POMR. Thank you.
Hello everyone, I'm Darien Sawyer, and I'll be going over the demo of how to use QL4POMR to input bedside information, and then show how that information is then connected to the bench. And to end it off, I'll go over some details on what we've been working on with the chatbots. So to begin, a quick outline of how you can navigate through the QL4POMR system. Like all GraphQL-based systems, it begins with a starting point and then an endpoint to get your data. So our starting point is with a query to read patients by ID, which I have set up here. And then the endpoint is just getting some basic information about that patient, be it their name, age, or location. And then if we run that, it'll pull that information from the database. And it just works the same for SOAP nodes. If you want to go into those, then you can go and find them like this, and then you can go deeper and deeper as you want for subjective, objective assessment and plan within the SOAP nodes. If you run that, we can see how many have been created, just one a few weeks ago. And so that's how you navigate through the system, but that's just reading. What if you wanted to mutate some information in the database? Well, in the past, what you had to do was get rid of this query and then write a mutation, which is a bit cumbersome if you need to go back and forth between mutation and queries a lot. So what we wanted to improve for bedside information input is bringing these mutations into the query themselves. So say we have some objective information that the user wants to input, but we see that there is no objective node in there right now. Instead of getting rid of the query and then writing a brand new mutation, we can just go back to the SOAP node itself and then create an objective right there. And then you simply write whatever information you have. We can say that the diagnostic data showed that everything was all good. Run the query there, and we can see that a new objective node has been created. And if we just check that, we can see that the information that we just put in is now in the system rather than having to get rid of the query, write a mutation, and then go back to it. It's much easier to input information from the bedside. So that is for creating objective, but then it's the same for updating as well as deleting. So we have the delete objective here. Run that, we see that it's been deleted. And then if we try to find that information again, we see that there is no more objective information there. So that's a very quick example of how to navigate through the system. The next thing we wanted to show for making it easier for bedside information input was bringing in the FHIR resources into QL4POMR. In the past, the FHIR server existed a bit independently of QL4POMR, so it was hard to merge the two. But now, I'll give you an example of FHIR resources within the subjective node. So, we have a patient medical history within the subjective, and you can see the data types that we've shown in the past that we created ourselves, which like allergies and demographics, which are just collections of text. It's not very complex. But what we have now is we brought these FHIR resources into the QL4POMR interface itself. So if you have a FHIR medication, rather than it just being a few lines of text, it is a much more complex representation of the medication itself using FHIR resources, and it's a much more standardized way of representing this information. So if you wanted to find some information about it, status and div, run that. And we need to give it the ID in order to find it. We see that it pops up here now as the FHIR medication within that patient medical history with that ID. And now it pops up in this side here. And so you can see now we have FHIR resources within the QL4POMR system. The next step, which I explained in a previous video, is bringing the international patient summary into this system as well. And rather than having that be independent of the QL4POMR system, we've brought it into the SOAP node itself. So within every SOAP node, you see we have the FHIR IPS data type here, which is the patient summary. And this keeps a collection of all the most important resources, FHIR resources that are kept within the SOAP node. So if you go through here, we can see we have spots for diagnostic results, medication summaries, medication statements, problem list, plan of care, all collections of resources that are stored within the SOAP node itself. And to show that they are the same, we want to view this medication that's in the patient medical history. We can see that it's also stored within the IPS. So if we go to text, ID, status, and div, see that the information stored within here is exactly the same. Now, in order to make the IPS actually usable on the bedside, it needs to be a constantly updated representation of information that's in the SOAP node. So in order to do that, we need to bring in the crude implementations, or the crude functions from the FHIR server into this one. And that's exactly what we've done. Just like I showed with the objective, you can do the mutations directly in the query here. So for the FHIR medication, if we want to update it, it's its own field there. And we say we want to return the ID for that. And then for the resource here, we just give it all the resource information that we want to update. So for the resource itself, it always requires that you specify what resource type it is for a FHIR resource. But then from here, we can change the information to whatever we want. So if we have text, then we can change the div to changed. We can change the status. And lastly, we want to change the ID just to show that it's working. Run that. FHIR medication. Run it one more time. So the first time you run it, it does the change, but it won't display it during that same query. If you run it again, then it'll show you that the information has been changed in the medication from the patient medical history, which is where we made the change, but then it's also changed in the IPS itself. So the user doesn't have to go and change it in both sides. It's automatically updated based on whatever changes you make up here in the SOAP node itself. So that is how you can navigate QL4POMR, how you can change information, and how we've brought FHIR resources and the FHIR IPS into the system. Now I'll go over connecting all this information to the bench, which is our main focus for this last phase of the project. So we've connected the system with two repositories as of right now. The first one being Open Targets, which has a large amount of information about drugs, diseases, and genetic targets. And we've also connected it to Drug Bank, which is which focuses more on drugs and drug interactions and things of that nature rather than diseases or genetics. So I'll begin with an example of how you can use it to get disease information. So for that example, we're going to be going to the assessment node of this plan, and we want to see the main diagnosis. So the main diagnosis here is leukemia. Now, if you wanted to connect this to information in Open Targets, the first thing you need to input into the assessment would be the EFO ID, which I already have inputted here. So you see we have an EFO ID right there that corresponds with leukemia. And once that's inputted, now we can query the disease data type, which in this system is taken from Open Targets using the schema stitching, because Open Targets has a GraphQL endpoint, which is convenient for us. So using that EFO ID as an argument, we go to the disease, and then say we want a description about that disease. It automatically populates that data type with the information that's in Open Targets. So you see we have the full description for leukemia. But say we wanted to use this information to see what type of drugs could be used to treat for this certain disease. So in the disease, we can search for known drugs, go to rows, we see the approved name, which would be the very specific scientific name, usually pertaining to what targets the drug goes towards. And then we can also, within there, go to the drug data type within Open Targets and see what the more commercial name is. So we run that. We see for leukemia, we have approved names with specific targets that this drug would go after, and then this more commercial name that's easier to find. And it lists all of the things that are in Open Targets. Makes it very easy for users to go directly from bedside information to the bench information if they're not sure what type of drugs might be used in a certain situation. Another example would be if a user wanted to see if medication that they're using right now could be replaced with a different medication that attacks a similar target or attaches to a similar target. So in order to look for that, we are going to navigate to the plan, and we have a discharge summary with medication that's been prescribed to the patient. And we see that we've prescribed acetaminophen to them. And we want to and say it's not doing the trick, and we want to find something better, but it attacks the similar targets. So in order to do this, it's similar to the disease, where in order to find a drug, you need to provide a Campbell ID and open targets, which we have here. Once that's given, we'll be able to query drug info. And using the drug type from open targets, you can see that we can query all the fields that are in open targets that correspond to that Campbell ID. So in this case, we want to search for linked targets that are associated with that drug, the targets that it's going after. Rows. And we want the names of all those targets, as well as known drugs that have been associated with that target. So, go for drugs, rows. I want to see the drug ID, and then go in a bit more detail about the drug itself, just for the more commercial name. Query that, and you can see that we have now gone through all the information that's in open targets. So from acetaminophen, we see all the different targets that it goes after, and then we see in what cases what drugs were used to go after that target. So for the first one, acetaminophen is used in most cases, but as you get farther down, or for different targets, I should say, so you have a different target here, some might have more options than others in terms of what drugs might be used in certain cases. So that's how a user could go through and see if a drug isn't working, what might be similar that you could use in that instance, just using open targets and the information that's in the bench database. The final example I'll go after does not use open targets. Instead, it uses drug bank, and this one is specifically for drug-to-drug interactions. So say a user has prescribed a medication like acetaminophen, but then they want to prescribe something on top of that, and they want to find out if it would have an adverse reaction, the drug-to-drug interaction between the two. So for that, we get rid of the drug info type here, and instead, using the same medication, we instead go to drug-to-drug interaction type. What we want is the interaction, and for this one, you have to give it the argument of the second drug that you want to input. So for this case, we're going to just say etomidate, run that query, and then it'll pull the interaction taken from drug bank rather than open targets, and then we see if we use those two drugs in combination, it would result in higher serum levels. So that's the example of how you can have a prescribed medication and then use the system itself here from the bedside, connect it to bench information in the drug bank, and see if there's any adverse reactions. So that's a couple examples of how we're connecting bedside information to the bench, and more is to come depending on other repositories that we connect to in the future. The last point that I will touch on for this presentation is our work with chatbots, which we worked on for the past few weeks on this project, and we'll go into the next phase. Right now it's in active development, and we can't show the user interface right now of the chatbots, but the basic plan is that we're going to be using a React dashboard to go and display the chatbot applications to a user. And the chatbots will be managed using tenants management, and this is where AWS Amplify comes in. Using the CLI, we're able to quickly inject Cognito user pools and APIs into the different micro front ends in order to authenticate whether a user should have access to that micro front end. So a patient user would only have access to the patient micro front end, which deals specifically with the subjective API. The physician would only have access to the objective API, or they could have access to the other one since they are a healthcare professional. Nurses could have access to the assessment one, and then anyone in a care management team would have access to the plan API. All these micro front ends would be used in order to quickly populate a SOAP note with information. It might make it faster for a patient to fill out the subjective information, and then a physician could go and fill out the objective information before the patient has even shown up to the hospital. It would be very helpful for automation and telemedicine in that regard. And then all the information taken from the chatbots here is then relayed back to the SOAP note in the larger QL4POMR ecosystem, which I just showed off, in order to connect the information taken from the chatbots and connect it to other services like open targets, drug bank, and any other features that are developed in the future. So that is all from me. Thank you all for listening. And if you have any questions, you can, of course, contact me or Dr. Mohammed or Dr. Fiaidhi. Thank you very much.